Right, so we're going to look at another question. This question is from 2008, paper 2A, question 5. So the question is as shown here. So let's read the question together. So figure 3.1 shows light ray traveling in water from a light source O. Okay, so light source O is here. So in figure 3.1, mark the critical angle and label as C. So this is a very interesting question because this three light source has three different incident angle I. So this is I1, I2 and I3. Now these three incident angles shows different characteristics. The first one is it refracts away from normal. The second one is refract to 90 degrees. Okay, because this is the angle of refraction. And then the third one is total internal reflection. Okay, because it doesn't come out from the water, but it goes back in. So these three criteria also shows that because this is from more dense water to air, so it is actually a critical angle judgment. So actually these three criteria shows the three conditions of critical angle. So the first one is if the incident angle is lesser than the critical angle, it will refract away from normal. So this is the case where it's lesser, you refract away from normal. If the angle incident is equal to critical angle, you refract at 90 degrees. And when the angle incident is greater than the critical angle, total internal reflection will happen. So using this information, we know that one of these conditions actually happens to be the critical angle, and it is no other than the second one, because in the second case, alright, when the angle incident, which is this angle, is equal to the critical angle, it will refract at 90 degrees. So in this case, the answer to the first part question is this is C, right? This is the critical angle. Alright, so using figure 3.1 is not drawn to scale. Using information in 3.1, calculate the critical angle of the light and show your working. So this is a little bit challenging, that's why it's 3 marks. Okay, so let me explain how you do this. So because all these three light rays are representation of the interaction between water and air, we can use the data from these three rays to calculate the refractive index of water first. Okay, now we know this total internal reflection will not tell you much because it's just angle incident equal angle reflection. This one will not tell you much because we do not know the actual angle. We cannot use a protractor to measure. If you use it, you will not be reading the question carefully because it says it's not drawn to scale. Alright, and then you also mentioned you have to calculate. So if you try to measure and then find the critical angle, you will get no marks. So you have to use this information to find the refractive index. So let's look at the formula again. So since this is the first condition where I is less than C, you will refract away from normal, and the formula is n equals sine R over sine I. So using this formula, okay, we'll be able to find the refractive index of water. The refractive index of water will be sine 42 over sine 30, which gives you 1.3. Now guys, sometimes you might mix up the two. Okay, you might put 30 above and 42 below. Now in that case, when you find your n to be less than 1, the quick solution is this. Remember, n must always be greater than 1. If you find your n is less than 1, straight away swap the numerator and denominator. Chances are this is the only mistake you have. Okay, once you swap it, you get an answer that's greater than 1. Chances are the answer is correct. Okay, so after you have done that, sin c equal to 1 over n. So using that formula, you can calculate it to be 48.4 degrees. Okay, so that's the answer. So let's move on to the last part of the question. Okay, so the last part of the question is a fiber optic question, right? So so the first question is they ask you to complete the ray to show how the light ray travels in the optical fiber. So optical fiber is actually a case where the medium inside is denser and the medium outside is less dense. It's like glass to air, alright? So because of that, if you draw the ray, you realize that this ray that I'm going to draw has a very large angle of incidence. Okay, so if you draw it until here and then you draw the normal, which is roughly at this point, you realize that the angle incidence is very large. So when an angle incident is very large, the chances are that you will always experience total internal reflection. So because of that, you will keep getting reflected. So in this case, it gets reflected, okay? And then after that, you have to draw the next angle incidence. And then you get reflected again. Okay, so remember to also draw the direction of the rays. And then you get reflected again. And then finally it goes to the other end. So that's how the light ray travels in the optical fiber. Alright. So the next question is explain why the rays does not escape from the optical fiber. Now this is a simple question because we already explored that it's going from dense to less dense, and also that the angle of incidence is greater than critical angle. So the answer is simply light ray is traveling from a denser medium to a less dense medium. Okay, so the first keyword is denser medium to a less dense medium, but the angle of incidence is larger than the critical angle. Okay, so because of that, total internal reflection happens and it will not come out from the medium. So that's how you answer it. Okay.